Okay, let's get started with Advanced Algebra 1. Hey, Kat. Hey, Alyssa. I'm doing my 5th period class this morning first, and then I will do Algebra 1, 6th and 7th period at about 11:30. Good morning, everyone. I am going to get things set up, wait for a few more people to get on, and then we'll get started. This is for 5th period, Advanced Algebra 1. Let me write 5th period up here. All right, let's see. Let me get my laptop set up so I can see who all's here. Good morning, Brittany. All right, I believe we will go ahead and get started. Today, I believe it's April 16th, I think. Let's see. Sunday, 14, 15. Yeah, I think today's the 16th. I lose all track of time when I'm not at school. Today, this is for 5th period Advanced Algebra 1. We're going to be dividing radicals, and I'll tell you, we're not going to do the harder lesson on this. This is the easier lesson, and then the next lesson, undividing, gets a little complicated, and it's not really that important, and I'm just sticking to the main important concepts that y'all need since we're not at school. I just want to stick with the most important ones that you'll need for future math classes, and the harder one on this, there's just really no point to do. So we're going to go ahead and do a little bit with division, just so you'll recognize how to work problems with fractions in radicals. And once we finish this lesson, that's it with radicals. We're going to be moving on, and we will have a test, a quiz, on all of the square roots. I will send it probably tomorrow, but it won't be due until Monday. All right, so let me see if anyone else joined. No, it looks like everyone left but you, Brittany. It's just us. All right, so our goals today, first of all, this is dividing radicals. We have 2 goals. One is to simplify radicals involving fractions. That's the overall main goal. And then some of our fractions are going to involve something called rationalize the denominator. We'll do that toward the end. So let's just get started with example 1. Let me first make sure that it's clear. It looks like it's kind of zooming in and out. I wonder if I slide it away from me. Alright, maybe that's pretty good. All right, example 1. We're going to simplify the square root of 15 over 4. Now, what you need to do is recognize that that entire fraction is under the square root symbol. And because that entire fraction is under the square root symbol, you basically have to take the square root of the top and the square root of the bottom. So like you would take the square root of 15, and then you would take the square root of 4 and write that as your answer, your fraction. So when you're working it, I'll just write it out that way. You think of it as the square root of 15 over the square root of 4. And the square root of 15, there is no perfect square that can divide into 15. So you just leave that, the square root of 15. But you can take the square root of 4, which is 2. And that is your answer, the square root of 15 over 2. Now, I want to back up and make sure that you understand something very important. Let me find a piece of paper to write on. If it ever starts out, let's just say that your problem was the square root of 15 over 4, like that. If the numbers are out of the radical, then you can't, like you wouldn't take the square root of that 4, because it's not, like the fraction wouldn't be inside the square root. Okay, so the only time you do it like what we're doing today is if both of the numbers are under the square root. Another thing, if you had the square root of 18 over 4, because this 18 is under the square root and this 4 is not under the square root, you could not reduce those like you would a normal fraction, because one's under the radical and one's not. You can't divide when they're both not under the radical. But now if it starts out with what we're doing today, if it was like this, with the 18 over 4 all being under the square root, then you would reduce that first. And we're going to have some problems like that today that you'll reduce before you do anything, because they're both under the radical. Okay, on to example 2. On this one, you have simplified the square root of 9 over 25. Now, they're both under the square root, so you're going to take the square root of each of them. And both of those are perfect squares. You're going to do the square root of 9 over the square root of 25. The square root of 9 is 3. And the square root of 25 is 5. So 3/5 is your answer. So they start out really, really easy. And on your IXL, I think you can get up to a SMART score pretty high on just these easy ones. Example 3. Here's one. Remember, always check to see if they can reduce first, because you want to make it easier on yourself. So you want these numbers to be as small as possible. 15 over 27 can reduce. When you reduce those, you can divide each of the numbers by 3. 15 divided by 3 is 5. And 27 divided by 3 is 9. So you get the square root of 5/9. And once you have that, then you look to see if any one of these numbers can simplify further. And 9 can, because it's a perfect square. So we're going to leave the square root over 5, because square root of 5 won't simplify. But the square root of 9 does simplify, and it comes out of the radical as just a 3. So that is your answer. Let me make sure you can see that. So you get the square root of 5 over 3. Make sure you don't have a square root over the 3. It's just plain 03. And that is your answer. Alright, on this page, the last one is the square root of 8 over 25. Okay, check to see if it can reduce. 8 over 25 will not reduce. So I'm going to go ahead and write it as the square root of 8 over the square root of 25. I'm going to come back up under here because I'm going to have to do a little bit more work. The reason I got to do a little bit more work on this one, because 8 has a perfect square factor in it that we have to take out. So right here, we're going to be left with the square root of 8. And we can take the square root of 25, which is 5. So 5 comes out of the radical. And then I'm going to go down here because the square root of 8 is not simplified. We have to simplify that. You always simplify square roots that have perfect squares that will divide into them. 8 is the same thing as 4 times 2. Okay, so we have the square root of 4 times 2 over plain 05. And then you take the square root of 4, which comes out of the radical as a 2. Left with a 2 on the inside. And then you've still got your 5 on the outside. So you get 2 on the square root of 2 over 5. Now, I don't think you will have any that do, but if this had come out as a 4, and the 2 on the outside and the number down here could reduce, you would reduce those. Okay, you can't reduce 2 over 5, but anytime both numbers on the outside can be reduced, you must reduce those. Alright, so let's move on to example 5. You still with me, Brittany? You understand these so far? Oh dear. Wi-Fi troubles again. Let me see if it straightens itself out. Alright, give me a second to see what I can do about this problem. There. Is it straightening out? I think it may be. Is it a little bit clearer now? Can you see that? Alright, example 5. Let me make sure if that stays clear. Alright, that looks pretty good. On example 5, you have the square root of 2k to the second. We're throwing in variables now. Over 9, and all of that's under the square root. So again, just like before, you take the square root of the top number, and then you take the square root of the bottom number and just write it as a fraction. So you can't take the square root of 2, but you can take the square root of k to the second. It just comes on the outside as k. Remember, you half your exponent. And then you're left with your 2 on the inside because you can't take the square root of 2. Now, 9, the square root of 9 is 3, so 3 comes on the outside. So you get k on the square root of 2 over 3, and that is your answer. All right, example 6. This whole thing, you can look at it and see that you're not going to have any square root left in your answer because 16 is a perfect square, u to the 10th is a perfect square, 81 is a perfect square. So we're just going to take the square root of all of those. The square root of 16 is 4, so it comes on the outside of the square root. U to the 10th, when you take the square root of u to the 10th, you just half your exponent, which is u to the 5th. And then it's over the square root of 81, which is 9. So there is no square root left. There's nothing left under the square root. And that is your answer. Sometimes after simplifying radicals, students get confused, and if their answer turns out to be a perfect square, like 4 or 9, they think you're supposed to take the square root again, but you don't, because there's no square root over it. It's just 4. It's just plain old 4 and plain old 9. So that's your answer. All right, example 7. Here's one, 22x to the 3rd over 50x. All of that's under the square root. So we can reduce these. So your first step is to reduce it and make it shrink so it'll be easier for you. So when you divide 22 and 50 both by 2 to reduce it, you get 11 over 25. Now the x's, let me make sure that's in view. The x's, you have an x to the 3rd on top and you have an x on bottom. Remember, if you have a fraction with the same variable, you subtract the exponents. So x to the 3rd divided by x is x to the 2nd, and it goes on top of your fraction because it's a positive 2 when you subtract those. So now you do just like we did up here in example 5. You are going to take the square root of everything. 11, you can't take the square root of it. So that's going to stay under the radical. However, you can take the square root of x to the 2nd. That's an even exponent. So you just half it. It comes on the outside. You've got your square root of 11 left. On bottom, when you take the square root of 25, that's just plain old 5. So you get x on the square root of 11 over 5. All right, these next examples, I think I have, let me see, it may just be these two. Oh no, it goes on. We have a few more because I want to make sure you get this next process. What we're about to do now involves our second goal, rationalizing the denominator. And I'm just going to write that over here. Rationalize the denominator. And you have to rationalize the denominator when you're left with a square root in the denominator, because you cannot leave a square root in the denominator. That's not allowed. So what we're going to do here, you can't reduce 3/5. So you're going to leave it as the square root of 3 over the square root of 5 for right now. That's what you're doing. You're going to take the square root of 3 over the square root of 5. Now, having a square root left on top, you've already seen, because we've already had that in previous problems, that's fine. But what is not allowed is having a square root left in the denominator. So we have to get rid of that square root symbol. And that's the process of rationalizing the denominator. And what I'm going to do now is just kind of show you the reason we're doing what we do. Because y'all know, I like for y'all to know the reason. Remember, our goal is to get rid of the square root symbol around that 5. So you got to think of what we've learned in the past on how to get square roots to cancel out. Remember whenever we were doing multiplication and you had something like the square root of 5 to the 2nd power, and you had to simplify that, and I showed you that that just means the square root of 5 times the square root of 5. which came out to be the square root of 25, which ended up just equaling 5. So whenever you squared the square root, when you multiply the same exact radical together, it makes the square root symbol disappear every time. So what we want to do is multiply this denominator by itself. But when you have a fraction, you can't just multiply part of the fraction by a number. You have to multiply all of it, just like you do it in an equation. And the reason is we don't want to change the value of this fraction. We want the value to stay the same. Well, if you think about what you learned back probably in 7th or 8th grade, if you have a fraction, let's say you've got 1/2, and I tell you to make an equivalent fraction. That means a fraction that has the same value, but the numbers look different. Remember, you can just multiply by any number. Let's say 3, as long as you did over 3. Because if you multiply 1/2 times 3 over 3, you're really just multiplying it by 1. 3 over 3 is just 1, so you're not going to change the value. And when you would multiply those, you would get 3/6, which means 3/6 is really equal to 1/2. Those are equivalent fractions. Well, we want to use that concept and this concept with squaring your radical to get rid of that square root symbol on bottom. So what you do is you multiply by 1 in the form of the square root of 5 over the square root of 5. Because you're going to then multiply your fraction straight across, and it's going to allow that square root symbol to cancel out. Okay, so that's what we're going to do. And you do it every time. You just take whatever number is in your denominator, and you multiply this whole fraction by that square root over itself. So you're going to multiply the square root of 5 over the square root of 5. And then when you multiply fractions, remember, you just multiply the numerators together and you multiply the denominators together. So the square root of 3 times the square root of 5 is the square root of 15. And the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 simplifies to just plain 5. And so your final answer is the square root of 15 over 5. Now you cannot reduce those numbers because this 15 is under your square root and this 5 is not. So you're done. That is your answer. And backing up to this process of rationalizing the denominator, whatever the square root is what you're going to multiply by over here on top and bottom. Alright, let me look over and make sure that it's still clear. It doesn't look like it's gotten fuzzy. Alright, we are moving on to example 9. Sorry, I had to drink some coffee. Alright, right here. The square root of 16 over 3k to the 8th. What I'm going to do is go ahead and separate that into two separate radicals. So you'll see how I'm thinking of it. It's the square root of 16 over the square root of 3k to the 8th. And now you take the square root of the ones that are perfect squares. So the square root of 16 is 4. And then on bottom you have the square root of 3k to the 8th. And you cannot take the square root of 3, but you can half your k to the 8th and bring it out as k to the 4th. You half your exponent. You don't really half the k to the 8th. You half your exponent. And then you're left with the square root of 3. Now remember, you cannot leave a square root or any radical in the denominator of a fraction. So we have to get rid of the square root symbol right here. This k to the 4th, we don't have to worry with it because it's not under the square root, so you leave it alone. We're just going to come out to the side and multiply by the square root of 3 over the square root of 3. Now, whenever you multiply 4 times the square root of 3, you don't multiply 4 times 3 like we did on the previous example, because this 4 is not under the square root. You just write it as 4 on the square root of 3. On bottom, I've run out of room, so I'm not going to show all my work. When you multiply the square root of 3 times the square root of 3, remember the square root symbols cancel out because you just get the square root of 9. And the square root of 9 is really 3. So that just comes out as 3, and I'm going to put my 3 in front of my k to the 4th. So remember, what you're doing is k to the 4th on the square root of 3 times the square root of 3 is k to the 4th on the square root of 9. And the square root of 9 comes out as 3, and you get 3k to the 4th. So again, this 3 and this 3 under the radical cannot cancel out because one's under the square root and one's not. And so that is your final answer. All right, Brittany, does that make sense? Do you need me to go back over any of those? We still have, I think, one more example to do. I'm waiting for your comment because you know it's delayed. Okay, moving on to example 10. Okay, you got it. All right, so we'll move on to example 10. We have 2 more examples. I just want to make sure that you understand this process of rationalizing the denominator, so that's why we're doing 2 more. On example 10, we've got the square root of 13 over 7k to the 4th. So I'm going to go ahead and separate it into 2 separate radicals. That's the square root of 13 over the square root of 7k to the 4th. Now, out of all of those under the square root, the only thing that's a perfect square is the k to the 4th, because that's an even exponent. So that comes out as, and I'm going to write it down here, that comes out as k to the 2nd. So you're going to be left with the square root of 13 over your k to the 2nd on the outside of the square root of 7. Now you tell me, what do I multiply by? And I know you can't really tell me, but I'm just giving y'all a second to think about it. We've got the square root of 13 over k to the 2nd on the square root of 7. What do I need to multiply by to get rid of that square root around my 7? And the answer is the square root of 7. So we're going to multiply top by the square root of 7 and the bottom by the square root of 7. Now multiply straight across, and these numbers you can multiply because they're both under the square root. So 13 times 7 is 91, so you get the square root of 91 over, when you multiply the square root of 7 times the square root of 7, that's just 7, plain old 7 without the radical, and then your k to the 2nd. And that is your answer. Oh, it went fuzzy again. Let me wait for a minute. See if that'll straighten out. it doesn't, maybe my phone doesn't like me. I give off some type of negative vibe. Makes it go blurry when I lean into it. Yep, see I backed up and it's straightening out. I think that's why all my watches that I wear go dead. I may have an electrical charge in me. Okay, example 11. I'm going to go back, though, over that example 10 because it was blurry while I was explaining it. So, we've got the square root of 13 on top, the square root of 7k to the 4th on bottom. And then I come down here, and I leave the square root of 13. I took k to the 4th, and I half the exponent because that's a perfect square. K to the 2nd comes on the outside, and you're left with your square root of 7. And then you have to multiply top and bottom by the square root of 7. Square root of 7 over square root of 7. These two numbers, 13 and 7, are both under the square root, so you multiply those and get the square root of 91. The square root of 7 times the square root of 7 is just 7 without the radical. So you have 7k to the 2nd on bottom. So your answer is the square root of 91 over 7k to the 2nd. And moving on to example 11. We have the square root of 20 over 40k to the 4th. First thing you should notice is 20 over 40 can reduce. It'll shrink those down and make it much easier to work with. So you want to reduce those. We start by reducing and saying it's going to be the square root of 1 over 2k to the 4th. 20 over 40 is 1/2. Need to move that over a little. So now we're ready to separate the numerator and the denominator into two separate radicals. So that's going to be the square root of 1 over the square root of 2k to the 4th. Now the square root of 1 is just plain old 1. 1 times 1 is 1. And then on bottom, you have the square root of 2 that's going to be left. 2 is going to be left in the radical, but your k to the 4th you can bring out as k to the 2nd. So k to the 2nd on the square root of 2. Now what do I multiply by? You want to get rid of the square root around your 2, so you're going to multiply by the square root of 2 over the square root of 2. So 1 times the square root of 2 is just the square root of 2. And then on bottom, the square root of 2 times the square root of 2 is the square root of 4, which just comes out of the square root as a 2. And then you have your k to the 2nd. So the square root of 2 over 2k to the 2nd is your answer. So this lesson wasn't too bad. I hope that you understand it. If you don't, I'm going to be, remember tomorrow I'll be doing a video call. And then if y'all need any help with anything, I'll be glad to help you. We are pretty much finished with, well, no. I forgot. We've got to do, this class has to do solving radical equations. So we are not finished with square roots. That means you won't have a test. I was confusing this class with my 6th and 7th periods. We have to do on Monday solving square root equations. And then you'll have a test on square roots. Your assignment for today is IXL, Algebra 1. We're going to go back and do, remember we skipped EE3, and so that's what this lesson is on. We're going to go back and do EE3. You need to get a SMART score of 84. I bumped it up to 84 because I wanted to make sure that you got one of these problems in where you have to rationalize the denominator. Alright, so get a SMART score of 84 on lesson EE3. And I hope you have a great day. Bye, Brittany.